In this section, we're going to take a look at set notation as well as solving inequalities. Set notation is a different way of representing an inequality, so we'll take a look at how that works. First of all, solving an inequality, very similar to solving equations. So in this case, we're going to want to find our common denominator so that we can multiply every term by that common denominator to get our denominators to cancel. In this case, our common denominator is 12. Multiplying each piece by 12. On the left-hand side, 12 divided by 4 leaves me with 3 times the numerator, which is greater than or equal to 12 divided by 3 leaves me with 4 times the numerator. And 12 divided by 4 is 3 again. Next, we'll distribute on both sides. Combine our like terms on the right-hand side. At this point, we need to get our x's together. I highly recommend that you move the variable with the smaller coefficient. As a reminder, when you multiply or divide an inequality by a negative, you have to flip the inequality. So if we move our 3x by subtracting it from both sides, instead of subtracting 4x and ending up with a negative coefficient, then we don't have to worry about that. Adding 5 to both sides. However, this one does present a different problem because x is on the wrong side of the inequality. We have to read it backwards to get our solution. So for graphing purposes, we have x is less than or equal to 14 when we read it from right to left. Setting up our number line, when I graph a simple inequality, I just put my solution in the middle and one value greater, one value smaller on either side. It's a closed circle. X is less than or equal to, and less than shades left. If you're ever wondering if you shaded the correct side of your inequality, grab a value, substitute it in for x. So we shaded 13. Is 14 greater than or equal to 13? That makes the inequality true, so we shaded to the correct side. Next, we're going to learn set notation. Set notation either involves parentheses or brackets. They can also be mixed. And what the parentheses represent is a less than or greater than. Brackets represent less than or equal to, or greater than or equal to. We also use parentheses if the infinity symbol is used when it's a single inequality versus a double inequality. So let's take a look at our first example. We have a double inequality. X is between but not including -6 and including 13. So the set notation to represent that inequality is a parenthesis, -6, comma 13 with the bracket. Again, the bracket represents the or equal to, and a parenthesis represents that it is not included as part of the solution. It's just greater than or less than. Our next example, we have an open inequality. So we use our parenthesis for 0 because it's not included, and this will go up to positive infinity. Infinity is not a number, so we will never use a bracket. We will always use a parenthesis if we have a negative or positive infinity. So x is greater than 0 can be represented by parenthesis 0, comma infinity parenthesis. The next piece with set notation is unions and intersection. Union is the combination of the two, and intersection is where they overlap. So this is use graphs to find each set. So first of all, this would be -4 is less than x, which is less than 0. We've got the two parentheses there. And the bracket one would be -2, less than or equal to x, less than or equal to 1. So if I graph these on a number line, I need to go from -4 up to 1. We have an open circle at -4. We have a closed circle at 1. And it's everything in between because it's the union. It's where either one is true. They don't both have to be true. Our smallest value is -4, our greatest value is 1. Figure out if we have an open or closed circle, and in this case, everything in between. Our next example, we are looking at an intersection. This is where they are both true. If you would like to get this done on one graph, I recommend using different colors. We need 2 through 4. For our first one, it is including 2, so we have a solid circle, and then up to positive infinity. For our second one, it is not including 4, so we have an open circle, and this one is going down to negative infinity. So where they overlap is our solution. In set notation, it includes the 2 and goes up to, but does not include the 4. If you wanted to represent that graphically, you would start at 2, have an open circle at 4, and shaded in between. When you look at our line graph, those are the only locations where we had the purple and the blue both shaded. So again, intersection is where they are both true. Union is where either or is true. Here are your 2 you-try questions. If you need some more clarification on that set notation, we'll work on that in class.